This is section 4.3, and we're going to be dealing with dividing monomials and polynomials. The first thing that we're going to look at is dividing by a monomial, which is one term. And there's a technique that we're going to use to do that. We will separate this problem out into three pieces. So we would say that's the same as 6x cubed over 2x squared minus 3x squared over 2x squared plus 2 over 2x squared. So you have these three pieces, and now we're just going to simplify. So when we simplify, 2 into 6 leaves 3. X squared into x cubed is going to leave x. Okay. Over here, the x squareds cancel out. And here, the 2's cancel out, and we are left with a 1 since there's nothing else up there. All right, so let's write what we have left. We have a 3x there. We have minus 3 over 2. And we have a 1 over x squared. And that will be our answer. So if you have one where you're dividing by one term, not two things added or subtracted as a divisor, this is the technique that we'll use. Now, when we divide by a polynomial, we're going to use long division. And you learned long division back in grade school. We don't do it too often because we have calculators. We do things on our phones even. So for just a minute, I want to go through a problem of long division and just remind you of the technique that you've always done with that. So if we were going to divide 638 by, say, 25, what goes in your head? What process? You want to think, how many times does 25 go into 63? Well, it goes 2. So we put a 2 up here. We don't put it over the 6. We move over and put it over that. Then what do? We multiply 2 times 25. That's 50. And what do? We subtract. I always put my subtraction in a little circle there because we sometimes, in regular polynomial division, we'll have negative signs all in there, and we want to remember we have this extra subtraction going on. So then we do the subtraction, and we're left with 13. What do we do next? We bring down the 8. So now we repeat the process, 25 into 138. And that goes about 5 times. So we're going to put the 5 here, repeat our process of multiplying, subtracting, and then we have 13 left. And what is 13? That's our remainder. All right, so we're going to use that same process with long division. So let's look and see how it goes in this. So here would be our problem. This polynomial divided by this, and this is not a one term. Remember, this is 2 terms. So we can't use that technique we had at the first. We're going to do our long division. We start out and we only think about this 2x, and how many times will 2x go into 6x squared? So you want to think about that it's actually, this is what you're looking at, 6x squared divided by 2x, and you're reducing that. 2 into 6 goes 3, x into x squared goes x. So you have 3x. You don't write it up here, you write it over the term that matches. So 3x goes there. All right. Then what did we do? We multiplied this times the whole thing. So 3x times 2x, 6x squared. 3x times 3, that's a positive 9x. And we're going to subtract. 5x minus 9x will give us a negative 4x. Actually, let's write that in this. All right. And then we brought down the next term, and we repeat the process. 2x into negative 4x goes a negative 2 times. I'm going to put negative 2 here. Multiply. We're going to have negative 4x minus 6, and we'll have a subtraction. All right, negative 10 minus a negative. So that's going to be negative 10 plus 6. It's going to give me a negative 4, and that's my remainder. All right? You sometimes will see this written as, instead of remainder 4, so you could have a remainder negative 4, or you could have minus 4 over 2x plus 3, where you put the remainder over the divisor. So either way is something that you might see in your problems. All right, the remainder theorem is one that you will see, and it says if f of x is divided by some factor x minus a number, the remainder is f of that number. All right, you don't have to memorize that theorem. Have to understand how it works. So if we were given this problem that said, if this is divided by this, what's the remainder? They don't want the whole answer. They want to know what the remainder is. Well, you can find f of negative 3. And the reason it becomes negative, it's in here. And remember, this is x minus a number. Well, the only way you get x plus 3 is if you had x minus a negative 3. So k would be negative 3. So you'll always change the sign when you do this. That means we're going to plug in negative 3. So negative 3 squared plus 8 times negative 3, plugging it into here, minus 17. If we do that computation, we get negative 32, and that would be the remainder if you did the dividing. It's a shortcut to get the divider. All right. You also have something called the factor theorem. F of x has a factor, x minus k, if and only if f of k is equal to 0. Let's see, that should make sense. We just found that f of k gives us the remainder. If the remainder is 0, that means it went in evenly, and it would be a factor. That will come into play in our homework. So just think about that. The last thing we're learning in this section is synthetic division. It's a shortcut for long division, and you can only use it if your divisor is plain old x, not x squared, 3x, anything like that. If you're dividing by just plain old x minus or plus something, then you can do it. All right, let's see how this works. You're going to take just the coefficients, that's the numbers. So we're going to take 3, negative 7. Now, do we have an x squared term here? We don't. We have to put a 0. Okay? And then minus 4 and a 5. You always have to put a placeholder if one of the terms in descending order is not there. We're going to put a backwards L. We're going to put the opposite sign of this number because remember it's in parentheses. When we pull it out, it becomes a positive 2. So I'm going to put a positive 2 there. Draw a line, and from then on we're going to be multiplying and adding. So we bring this number down without doing anything to it. It's just going to be a 3. Then we multiply. 3 times 2 is 6. We put it here. Go ahead and do this adding. Negative 7 plus 6 is a negative 1. Repeat that process. Negative 1 times 2, negative 2. Add, get negative 2. Negative 2 times 2, negative 4. Sorry. Add, you get negative 8. Negative 8 times 2, negative 16. Add, and you get negative 11. So we have our answer, but we have to put the x's back in. So here's something important. Whatever you started with, you drop down one level. All right, so if we're dropping down one level, instead of x to the 4th, we'll start with x to the 3rd. All right, so we'll have 3x cubed minus 1x squared minus 2x, we're just going down the line, minus 8 with a remainder of negative 11. And that would be our answer. Now, in your problem, sometimes they give you two boxes. This is the quotient. This is the remainder. And they may ask you to fill those in separately. So in case they do, you know those two parts. Okay? All right, let's look at the problem set and see what we've got. All right, divide the expression. And this is like that one that we had where we were dividing by a monomial. So over here we could have 8x cubed divided by 12x minus 4 over 12x. We're going to simplify each part. 4 goes into 8 and 4 goes into 12. It goes into 8 2 times, goes into 12 3 times. X goes into x cubed x times. So we have, x squared. So we have that up there. Over here, 4 goes into 12 3 times. You have a 1 left up there, and the x is there. So let's see what we've got left in our red. We've got 2x squared over 3 minus 1 over 3x. All right. If we go to number 2, see if we can get some room here. This is using ordinary division. Now, if you notice, we are dividing by w minus 3. That's fine. We can use synthetic division. So let's do that. We need to note, do we have anything missing? We do. We don't have a plain old w term. So when we do this, we've got to write in the placeholder. So we've got negative 4 plus 6. Oh, I don't need to put the plus. Sorry. Negative 4, 6, 0, and a negative 7. Backwards L, and what goes in there? Positive 3. All right, we'll do this. We'll come down with this guy. Negative 4 times 3, negative 12. That'll be a negative 6 here. Negative 6 times 3, negative 18. We add, we get negative 18. Multiply, negative 54. And add there, we get negative 61. All right, we started with w cubed, so we end up with w squared. So we have negative 4w squared minus 6w minus 18, remainder negative 61. Can't make that be right. So this is the quotient, and it is going in that box there. And then the remainder is going to go in the other box. All right? All right. Number 3. This is dividing by 7x, so we're not going to be able to do synthetic division. So we need to do full out long division. And we don't have to put any zeros. We've got cubed, squared, a 1, and a constant. So we're good there. So let's write this over here. 14x cubed minus 59x squared minus 60x minus 12 divided by 7x plus 2. All right, 7x goes into 14x cubed, 2x squared times. So we're going to put 2x squared here. We're going to multiply. 2x squared times 7x gives me 14x cubed. 2x squared times 2 gives me 4x squared. And subtract. So negative 59 minus 4 gives me a negative 63x squared. Bring down this term. 7x into negative 63x squared goes negative 9x. Multiply. Negative 63x squared and a negative 18x. That's negative 9x times 2. Subtract. Negative 60 plus, because you got two negatives, 18. It's going to give me negative 42x, bring down the negative 12. 7x into negative 42x goes negative 6 times, multiply, and you have 0 for a remainder. So your answer is right here. No remainder. All right. Number 4 says use the remainder theorem to find the remainder. Well, remember, we can just do f of positive 3. Even though this isn't in parentheses, we can do that. All right. So use the remainder theorem. We're going to say f of positive 3 equals 4 times 3 squared minus 6 times 3 plus 7. And when you do that out, you should get 25. You could also do synthetic division and actually find the remainder, but this is what we're asked to do, so I'm going to check with that. All right. 5 is the same thing when we're dividing by x plus 4. So we're going to do a f of negative 4 in our equation. Negative 4 cubed minus 8 times negative 4 squared minus 17 times negative 4 minus 7. And when you do all of that, you actually should get negative 3. Okay. All right, use the factor theorem to decide if k equals negative 5 is a factor. All right, remember, we're going to do synthetic division. So we got 3, 14, negative 9, negative 20. And we're going to divide by negative 5. Now, we don't have to change the sign because it's not in an x minus or plus form. It's just the solution. So we're going to do that, and our goal is to see what this remainder is right here. So that comes down, that goes there, negative 1, positive 5, negative 4, positive 20, and 0. Well, because we got 0 for a remainder, then it is a factor. So that's the thing. If we get any other kind of number here, the answer is no. Let's look at number 7. We got 3, 11, negative 8, 20, and we're trying negative 4. So 3, negative 12, negative 1, positive 4, negative 4, positive 16. Oh, this was a negative, sorry. And that's a negative 4. That's my remainder. So that can't be a factor. All right. Number 8 says factor this into linear factors given that k is a 0. So we've got an x cubed thing. What we're going to do is do synthetic division and whittle this thing down into quadratic. So we have a 1, a 7, a 2, and a negative 40, and we're dividing by a negative 5. Bring that down. We got 1, negative 5, 2, negative 10, negative 8, and a positive 40, and you should get a 0 because you're dividing by a factor. Now, if we were doing regular division, we would say, well, we started with x cubed. We now have x squared plus 2x minus 8. And we want to factor this. All right? So if we've got that, factors of 8, 4, and 2. So let's say x plus 4, x minus 2. And your answers are supposed to go up here in this box. So it's x minus, we're going to put in a 2 there, and x plus, and we're going to put in the 4. So that's how you're going to put it because it's got it in that factored form. You're going to do the same thing with number 9. All right, number 9, so we'll start out with a 1, an 8, a 4, a negative 48. We're dividing by negative 6. We have a negative 6, a 2, a negative 12, a negative 8, and a positive 48, and we get a 0. So, back into x form. X squared plus 2x minus 8. That's exactly the same kinds of answers. That's weird that that's going to come out exactly the same. All right, so we're going to have x plus 4 and x minus 2, and they go in the same way up here. Plus 4 and minus 2. That's unusual. All right, 2 more questions. Solve by factoring. I wanted to throw this one in to remind us about factoring by grouping. When you have 4 terms, sometimes we can look at these in groups. All right, what could I factor out of these 2 terms? I could factor out n squared and be left with n minus 2. Okay, over here I need n minus 2 to work here. That would change both those signs, so if I pulled out a minus 1, that would work. That'd give me minus n plus 2. All right, now you want to look at it and say, okay, what's common in both these pieces? The n minus 2. So n minus 2 comes out. What's left? N squared. And here, what's left? Minus 1. So what we did was rearrange this from 4 terms, 4 terms that are added or subtracted to 2 things that are multiplied. This one factors into, because it's the difference of 2 squares, so it factors to n minus 1, n plus 1. And then we have this n minus 2. It asks for the solutions. These are the factors. So this gives us n equals 2, n equals 1, n equals negative 1. And those would go up in the box with commas. All right. Last question says approximate graphically the complete factored form. So you're going to pull your calculator up. We are going to clear all of this business down here. I do not need to have dot mode. So regular mode. All right. So I am going to put in x to the third minus 2.4 x squared minus 4.8x plus 4.9. All right, I'm going to graph that. Okay, now the complete solutions are the x-intercepts. I kind of need to see those a little better, so I'm going to do a zoom 4. It's going to zoom in for me a little bit, because really what I need are these 3 things here. So you want to do, you also want to have under y equals y2 to be 0. That will allow us to do that intersection thing. All right, so second calc, number 5 intersect. For the first one, let's just hit enter 3 times. 1, 2, 3. Pops to this one. And we're supposed to round to the nearest tenth. So that's 0.8. Okay? So I'm going to write down x equals 0.8. I'm going to go back in. Second calc 5. And I want to go over and get closer to the first one. All right, and hit enter 3 times. And you have negative 1.79, so that'll be negative 1.8. So So I'm going to come over here and put x equals negative 1.8. So I've got two of them. Need to get the third one. Second calc 5. And I've got to move all the way back over. Okay, hit enter 3 times, and I get 3.39, so that'll be a 3.4. All right, so I have the solutions, but it says type it in factored form. Remember, factored form is x minus whatever the solution number is. So this will be x minus a negative, so that'll be x plus 1.8 times x minus 0.8 times x minus 3.4. And that's what goes in the box. No commas in between. Those are factors. And that should get you going on 4.3.